All right, so today's October 24th, and so just a few things to talk about here. First of all, today we're going to start in on chapter 10 in your textbook, and we're talking about solving quadratic equations. That's our next topic. We've already talked about that some this semester, but there's still lots of quadratic equations that we can't solve with the methods we've talked about in class. And so we've got to return to that again. And part of that involves square roots, and that's one reason why we've been talking about square roots so much over the last couple weeks. So today we'll look at several other methods for solving quadratic equations. Also, let's once again write down some things about this week. You guys should have been getting some emails from me about various things about this week. And first of all, today, so that's Tuesday, I'm going to be on campus for on-campus office hours from 4 to 6 p.m. this afternoon. So I'll be there this afternoon. And remember, my office is in Winship 115K on the North Harris campus. So I will be there from 4 to 6 today. No online office hours tonight. No online office hours. All right, then Wednesday. So tomorrow, I will be on campus again from 11 to 1 p.m. So again, another time when you can come by for help. Once again, no online office hours that day. And then on Thursday, the testing window opens, so exam 2 testing window opens. And it's October, remember, it's October 26th through the 31st where you can take the exam. And then I do have Sunday and Monday evening office hours. So I'll be online office hours those 2 days. And on Sunday, remember, they go from 7:30 to 9 p.m. And on Monday, go from 8 to 9 p.m. So that gives you 2 more opportunities to ask questions before the exam window closes. I want you to pay attention to WebAssign due dates, definitely, because you have some assignments that are coming up that are due. And, see if you can meet those deadlines. I believe, if I'm not mistaken, it's tomorrow are the due dates for the next group of assignments. Also, I had people for my online office hours. I had people online last night for an hour, and I had 3 people in particular that logged in last night, and we worked for an hour on problems. So definitely online office hours are a great opportunity for you to get online through my WebEx room and get some questions answered. So, all right, so today we're going to probably have a little bit of a shorter lecture than usual, but so that I'm sure is not upsetting to most of you. But before we get started, do we have any questions that anybody wants to ask before we get started? Anything anybody's got? Thank you, Jose. I'm not hearing anything from anybody else, so I'm assuming no other questions. Brandy, I can hear you, sort of, yes. I can hear you, Brandy. What do you have a question?
No, I don't have a question.
Okay.
I wanted to see if you could hear.
I definitely can. So Brandy, as I'm going through lecture, talk a little bit louder probably, but if you have a question about something, stop me as we're going through the lecture, okay? Don't let me just keep on talking. All right. So if you don't understand something, slow me down, okay?
Okay.
All right. Sounds good. All right. So today we're talking about quadratic equations. Now remember, first of all, what a quadratic equation is. We've been talking about quadratics frequently over the last month or two of the semester. But remember, a quadratic equation is an equation that can be written in this form: ax squared plus bx plus c equals 0. And the key here is that first term, it's a second degree equation, second degree polynomial equation. And as soon as you see that squared term and there's no other powers bigger than 2, then you know you've got a quadratic equation. So for solving these kinds of equations, so I'm talking about methods for solving, we have talked about solving quadratics already. And the first method that we have looked at and we've used frequently over the last couple months, or at least month and a half of the semester, is the factoring method. In other words, using what we call the zero factor theorem. That theorem goes by several different names. Remember, that's just, if you have two numbers multiplied together to give 0, then one of them's got to be 0. Right, and so we've used that method frequently during the semester. So when you have an equation like x squared minus 5x plus 6, you could solve that equation easily by factoring x squared minus 5x plus 6. As a trinomial, it factors x minus 2 times x minus 3, and then just setting each factor equal to 0. Right, and you get x equals 2 and x equals 3. So factoring works just fine, and those are our solutions right there. Factoring works just fine as long as the expression that you've got in the equation is factorable. But if it's not factorable, then you got problems. And so far this semester, all the equations we've looked at, when you hit a quadratic somewhere, you're guaranteed that it's factorable. A trinomial like this one, or maybe the difference of squares, like this one, 4x squared minus 25 is the difference of two squares. And you could set those factors equal to each, so you factor it 2x plus 5 times 2x minus 5, and then set those two factors equal to 0. Right, and then that gives you negative 5 halves and positive 5 halves. So that's another way that we've seen quadratics factor. And then finally, if you had 7x squared minus 35x equals 0, you could get a GCF. So we've had trinomials when you are using the factoring method to solve a quadratic. You've got the difference of squares right here, and then you've got GCFs right here. Right, you could take out a 7x right here, and you're left with x minus 5. And then you set each of those factors equal to 0. And you end up with x equals 0 and x equals 5. Now, we've encountered all of those situations during the semester, and those are all pretty routine as far as factoring it and then setting the factors equal to 0. But again, not all quadratic expressions factor one of those three ways. And so the question is, what do you do if the expression's not factorable? So what do you do if the expression is not factorable? So what we're going to do is we're going to look at 3 more methods for solving quadratics. 3 more methods. Now the first method is called the first new method. So I'm going to call this method 2 because the first method is factoring. But method 2 is called the square root method. And this method does not work all the time. It's just like factoring. It doesn't always work. But when it does work, it is easily the easiest method to use. And that's why it's a good method to know, because when you can use it, it works fast. And it's very simple to use. This method only works when you've got an equation, a quadratic equation in a very special form. It's got to look like this. Something squared equals a constant. And then when you get an equation that happens to be in that form or happens to be something you can put easily in that form, the square root method works out really nicely and really quick. But it doesn't always work, so that's the downside of the square root method. The third method is completing the square. And completing the square always works, first of all. It always works. For any quadratic equation, you could always solve it by completing the square. But the problem is with completing the square is that it's a harder method to use. And so it's not a method of choice, really. You don't really like to use it because it's a more difficult method in general. And so we're going to look at completing the square. We're going to talk about it now. It's an important method in college algebra, for example, for other things besides solving quadratics. Graphing parabolas, graphing circles, things like that, completing the square comes in really handy. But for solving quadratics, we usually aren't going to use it. Its other main use is that it allows us to derive the fourth method, the fourth and final method, which is the quadratic formula. And using the quadratic formula to solve a quadratic. Now, the quadratic formula is something we have to derive, and we derive it using completing the square. But this is actually a formula that allows you to always solve a quadratic equation. And again, it always works. For any quadratic, you could solve that quadratic by the quadratic formula. And again, the quadratic formula is harder than the square root method, and it's harder than factoring. So factoring method and the square root method are good methods to know because if they work, they're faster. And then the quadratic formula is kind of like your fallback if the first two methods don't work. All right, so we are going to dive in here and look at some examples with the square root method and talk about that method. And then we're going to look at completing the square. We're going to look at some easy examples of completing the square. I don't want to spend a big amount of time on that. And then we'll finish with the quadratic formula, and we may actually get to the quadratic formula today. The square root method, again, is only a method that works if you have the equation in this nice special form that I'm highlighting right here. Something squared equals a constant. If you can get the equation to look like that, then you can use the square root method. And so we're going to start with some very simple equations that look like that. And then we'll work our way up to a little bit more difficult equations. So if you just have something like this, x squared equals 49. Very simple equation. It is quadratic because it's got that x squared in it. It's not in ax squared plus bx plus c equals 0 form, but it doesn't have to be in order to be a quadratic. Remember, the thing that makes it a quadratic is that second degree term and the fact that there's no other term bigger than 2 in there. But this equation is in the form something squared equals a constant. And it's also an equation that is super easy just to solve, in your head, because what is this saying? This is saying what numbers, when you square them, give you 49 when you square them. And there are two solutions to that equation. There's two numbers that you can square to get 49. You can get -7 or you can get 7, right? -7 squared is 49, and so is +7 squared. It also gives you 49. So those are both solutions to this equation. Now 7 happens to be the square root of 49, and so when you have an equation like this, what we can talk about is that an easy way to think about solving this is that what you're doing is taking the square root of both sides of the equation. Take square root of both sides of the equation. But you have to allow for the fact that there's both a positive and a negative solution. So when you take the square root of both sides, so you have the square root of x squared and you have the square root of 49, you have to allow for the fact that there could be both a positive and a negative solution, and so you put a plus or minus in front of the constant like that to take it to account for the fact that there's both a positive and a negative solution. And so the square root of x squared we would write as x, and then you get plus or minus 7. And that would be our solution right there. Right, very simple to solve that equation. All right, and so the idea here is to take the square root of both sides of the equation. Right, that's the whole idea behind the square root method. But you do have to allow for the fact that there's a positive and a negative solution to the equation. So you have to remember to put the plus or minus. By far and away, the single most common mistake students make is to forget to put the plus or minus there and to account for that. So that's something to definitely watch for. All right, next equation. So what we're going to do is we're just going to, you know how to solve quadratics using the square root method. You have an equation in the form something squared equals a constant. You take the square root of both sides of the equation. What we're going to do now is just gradually work our way through different situations that you're going to encounter so that you know what to do when you get to them. So we'll look at another equation just like the one we just did. X squared equals 81. Something squared equals a constant. So we take the square root of both sides of the equation and make sure we put a plus or minus in front of the constant, and we get x equals plus or minus 9. That would be our solution set, positive 9 and negative 9, which is pretty obvious from the way the equation is written, right? That you're looking for something squared to give you 81. All right, now this equation is a slightly more complicated. You get x minus 3 squared equals 25. So the expression that's squared is slightly more complicated. But the deal is still the same. You take the square root of both sides of the equation. Take the square root of both sides. Right, so x minus 3 squared, its square root would be x minus 3. And then equals, and then over here, make sure you put the plus or minus, and then this would be the square root of 25. Now the square root of 25 happens to be one that I know, so I would go ahead and write it out as plus or minus 5. Now the only thing that we haven't done here is we haven't solved for x. So we've gotten rid of the square in the equation, but now we need to solve for x. So now solve for x. And so you add 3 and you get x equals 3 plus or minus 5. And we usually put the 3 at the beginning on this problem and not at the end. You can put it at the end if you want, but I typically put it in front of the term that's got both the positive and the negative. So now don't leave it like this. This gives you two solutions, 3 plus 5 or x is equal to 3 minus 5. So you have to finish this, and in this case you can do the arithmetic. And so you get 8 and negative 2. And so 8 and negative 2 are going to be our solutions. You could certainly check those. You go back to the original equation, and if you check, let's say I check negative 2, for example. You go back to the original equation, you put negative 2 in place of x. I put a question mark over the equal sign because that's what I'm checking to see if they're equal. And notice you get negative 5 squared equals 25, which is 25 equals 25. And so it does check. Right? Both solutions that we got are going to check in this case. Okay, so that one's slightly more difficult. Let's look at another equation. X plus 2 squared is equal to 7. X plus 2 squared is equal to 7. This equation is in the form something squared equals a constant. So we're ready to take the square root of both sides of the equation, right? That's what we do when we get the equation in that form. We take the square root of both sides. So when we do that, the square root of x plus 2 squared is hold on real quick here. All right, so when you take the square root of both sides, you get x plus 2 is equal to, don't forget the plus or minus, and we get plus or minus, in this case, the square root of 7. Now notice the difference between this equation and the previous one is the square root that I get. Here is the square root of 7. here I got the square root of 25 on the last problem. And so when one of those you could evaluate, the other one you can't evaluate. All right, hold on real quick here. If you guys would just pause for just a second, I just have. All right, so one of those you had a perfect square, and the other one you didn't have a perfect square, and so one of them you went ahead and evaluated. So the square root of 25 was 5, but on the other ones, the square root of 7, I can't do anything with that, so I just have to leave it as the square root of 7. And so we solve for x here, and so we subtract 2 to solve for x, right? Subtract 2 from both sides, and so you get x is equal to, x is equal to -2 plus or minus the square root of 7, like that. And in this case, the square root of 7, like I just said, it can't simplify, and so in fact, there's nothing you can do there, and that would be your solution set. By the way, on WebAssign, so is there a question from anybody?
Yeah, I do have a question.
Brandy, go ahead.
Why do you put a square root on the 7 if it doesn't simplify?
Well, remember what you're doing in the original equation. You have x plus 2 squared equals 7, and to solve that equation, you've got to get rid of the square. So how are you going to get rid of the square in there to solve for x, right? And so the way with the square root method, what you're doing is you are taking the square root of both sides of the equation. So notice at the bottom there, notice how I took the square root of both sides of the equation. You can't just take the square root of one side, you got to take the square root of both sides. And so notice every time I was writing this out, they emphasized the word both there, right? I had to do it to both sides. Now, and so the square root of x plus 2 squared, right? When you take the square root of something that's squared, you're left with what's underneath the square root. So I evaluate that and get x plus 2. That gets rid of the square there. But the 7, there's nothing I can do with that as far as the square root of 7. It doesn't simplify, so I'm stuck with that. Now, the only other thing you have to remember is to put a plus or minus in front of that. So you remember, you are taking the square root of both sides. It's just that the square root on the left side dropped out because of the square that was already there.
Okay, thank you.
Does that make sense?
Yes.
Okay, good question, good question. All right, so let's look at another problem. Let's say we have x minus 5 squared is equal to 20. All right, so Brandy, this is exactly like the last problem, right? And we're going to take the square root of both sides, right? And I'll go ahead and show that on this one again. So you're taking the square root of the left side, you're taking the square root of the right side, you got the equal sign there, and then you don't forget a plus or minus there also. So the square root of x minus 5 squared, right, that's just x minus 5. So that drops out, the radical drops out there because you're taking a square root and you're squaring both. So it's kind of like, remember, they undo each other. On the other side, the square root of 20 is, the 20 is not a perfect square, but it does simplify. And so you do simplify the radical. Now remember, we've been talking a lot about this over the last couple weeks, or the last week and a half at least. And so you break it up into two factors where one of them is a perfect square. So I take 20 and I break it up as 4 and 5. You don't break it up as 2 and 10, remember, because 2 and 10 are not perfect squares there. And so that gives you x minus 5 is equal to plus or minus 2 times the square root of 5. And then go ahead and add 5 to solve the equation. And so you get 5 plus or minus 2 times the square root of 5. Like that. Always put the 5, when you're adding 5 to both sides, put it in the beginning. Don't put it at the end. Put it before the radical and put it as a term in front like that. Now remember, the 5 and the 2 at the end there, I can't add. And so you're stuck with the solution looking like that one right there. So you get 5 plus or minus 2 square root of 5 is your solutions, right? Those are the two separate solutions there. Also, don't forget on WebAssign, when you work problems like this, a lot of times it's going to tell you to enter the solutions is a comma separated list. That's the way it's going to be worded, is a comma separated list. And so on WebAssign, it'll come up a lot of times and it'll have an X equals, and then there'll be a box here to put your solutions in. And in this problem right here, what you'd have to do is you cannot enter it as plus or minus. You would enter it as 5 minus 2 square root of 5, comma, and then 5 plus 2 square root of 5. You have to enter each solution separately, separated with a comma like that. And so when you see that in WebAssign, that's what they're talking about, is to enter the solutions one at a time and not to use the plus or minus, and then separate the solutions with a comma like that. So I wanted to mention that. Okay, so on the...
I have another question.
Okay, that's okay, Brandy. What's up?
Going back to the one you just did,
okay.
How do we know when to separate the square? Like you separated the 20. How do you...
Anytime the number has a square has a factor that's a perfect square, you got to do that, right? So, square root of 15. What are the only factors of 15, Brandy?
2 and 5. I mean 2 and 10. Sorry.
No, wait, 15 now, Brandy. What?
Oh, 3 and 5.
There you go. So 3 and 5, right? So 1 and 15 and 3 and 5. But are any of those perfect squares?
No.
No. And so you can't break up the square root of 15, right? There's no perfect squares in that list anywhere. And so it doesn't simplify, right? But the square root of 28, well, the factors of 28 are 1 and 28, 2 and 14, and 4 and 7. And there is a perfect square sitting in there, isn't there? There's the 4. And so it's square root of 28, you have to break up.
So you only break it up when there's a perfect square in the number.
A perfect square is one of the factors. That's right.
Okay.
Right. So 15 doesn't break up, doesn't simplify. Square root of 28 does simplify. Right. That's exactly right.
Okay.
All right. And okay. So let's keep on going. Let's say we have 3x plus 2 squared is equal to 8. 3x plus 2 squared is equal to 8. So is that equation in the form something squared equals a constant? Absolutely. And so you take the square root of both sides of the equation, right? So I'm taking the square root of both sides. Take the square root here, take the square root here. I have to remember to put a plus or minus, right? And so this gives me 3x plus 2 equals, and now I've got plus or minus the square root of 8. Brandy, you and I were just talking about this, right? The square root of 8. 8 does have a factor that's a perfect square, and that's 4, so you do have to simplify this. You have to break it out. So the square root of 4 times the square root of 2. And so you get 3x plus 2 is equal to plus or minus 2 times the square root of 2. Now we have to solve for x. And to solve for x, you actually have to do two things here. You have to first subtract 2 from both sides. So I do that. And remember, put that negative 2 on the right side, put it in front. So you have negative 2 plus or minus 2 square root of 2. But then I also have to divide both sides by 3 to solve for x. And so I end up with x equals negative 2 plus or minus 2 square root of 2, all divided by 3. And that's my solution right here. Like that, right? That's my solution set. All right, everybody's okay? All right, next problem. So we're just looking at different situations as we go through these now. Now the next problem, I have x squared equals negative 9. So it looks like a little bit simpler of an equation, and it is, but there is something that comes up here that we haven't talked about. So you take the square root of both sides, and I put a plus or minus there. Square root of x squared gives me x, And then the square root of -9. Remember, when you've got the square root of a negative number, you get an imaginary solution. Remember, don't forget that the square root of -1 is equal to I. We just came out of that, talking about that in the last lecture. So square root of -1 is equal to I, and so this would be plus or minus 3I, right? Remember, when you have the square root of a negative number, you don't get a real answer, you get an imaginary answer. And that's going to happen in some of these quadratics, that you end up with imaginary solutions. You end up with plus or minus 3I. Now, if the instructions on this problem said, find all real solutions, well, this equation has no real solutions, right? When you have the square root of -9, those are not real numbers. And so if it said find all real solutions, then the solution set here would be no solution, because there are no real solutions to the equation. All the solutions to this equation are imaginary. So just be aware of the fact that you, like on WebAssign especially, you may see that in the instructions. It may say find all the real solutions to this equation. If it does that, then you don't worry about imaginary solutions. Now on exam 3, I will give you some problems where there are imaginary solutions, just so you know that that's going to happen. And I'm going to ask you to write the imaginary solutions also. That's exam 3. We're not ready for that in exam 2 yet. All right. Still a little bit left to do with the square root method. So let's say we have 2x minus 5 squared minus 40 equals 0. Now this particular equation is not in the form something squared equals a constant. And so that's the first thing you need to do, is put this equation in the form something squared equals a constant. Right? You got something squared minus 40 equals 0, and so it's not something squared equals a constant. So add 40 to both sides, and now it is in this form that we need for the square root method. Something squared equals a constant. All right, and now we're ready to use the square root method. And so we take the square root of both sides of the equation, put a plus or minus there, right? And so we get 2x minus 5 is equal to, and again, Brandy, you and I had this conversation a few minutes ago, 40 does have, right, factors. You know, if you list all the factors of 40, you get 2 and 20, you get 5 and 8, but you also have 4 and 10, and so 40 does have a factor that's a perfect square, and that's 4. So you break it up as the square root of 4 and the square root of 10, and so you get 2x minus 5 equals plus or minus 2 times the square root of 10. All right, and now go ahead and solve this equation for x. So I'd add 5 to both sides. And so you get 2x. Don't be tempted to add the 5 and the 2 together, because the 2 is multiplied by the square root of 10, and you'd be violating order of operations if you did that. So just put the 5 out in front, plus or minus 2 times the square root of 10, like that. And then divide both sides by 2. And so when you do that, you get 5 plus or minus 2 square root of 10 divided by 2. Now, we need to go back over this again. We have talked about this back in the last chapter, but fractions like this are going to be common when you're solving quadratic equations. And the question is, when can you simplify and when can you not simplify? These 2's cannot be canceled in this problem because 2 is not a factor in the numerator, because you have that addition and subtraction in there. And so this one is simplified. Right? You cannot cancel, don't cancel the 2's. Right here, right? Because that 2 in the numerator is part of an addition and subtraction problem. And the only time you can divide it out is if it's a multiplication problem, remember. Now, if this had been, for example, 10 plus or minus 2 times the square root of 10 over 2, Now you can simplify it, and the reason why is because the 2 is common in both of the terms in the numerator. And so you can factor a 2 out of the numerator like that. Just pull a common GCF of 2 out, and then you have over 2. And then see, now the 2 in the numerator is a multiplication problem, and you can divide it out. And so you just end up with 5 plus or minus the square root of 10, technically over 1, which is just 5 plus or minus the square root of 10. From a practical standpoint, the way most students look at this is if there's a common factor in all 3 parts of a fraction like that, then you can divide it out. So when a student sees 10 plus or minus 2 square root of 10 over 2, they see a common factor of 2 in all 3 parts. And if it's in all 3 parts, then you can divide it out, right? And then write down what you've got left after you divided it out. So in this case, you get 5 plus or minus the square root of 10 over 1. So in this problem, 8 plus or minus 12 times the square root of 3 over 16, right? You see how there's a common factor in all 3 parts of 4. And so this one can be simplified. I can divide a 4 out of all 3 parts right there. And when you divide the 4 out, so let's see, divide out a 4. Right, and when you do that, you are left with 2 plus or minus 3 square root of 3 over 4. But notice if this had been 9, let's not say 9 right there. Let's say 8 plus or minus 9 square root of 3 over 16. You see how there's not a common factor in all 3 parts. The 8, 9, and the 16, there's no common factor. And so this one is simplified, right? There's nothing you can do with this one, right? No GCF in all 3 parts on this one. And
On
so,
the exam, do we have to simplify?
yes, always. Because what you're doing is reducing a fraction. And so you were going to always write your answer in a simplified form. Absolutely. Yeah, I'll always want you to reduce the fraction. Yep. In mathematics, just in general, what we will always want to do is get in the habit of writing our answers in as simple a form as we can. And so that's what you're doing right there. Now, Brandy, if, like on a test, let's say this is a 5-point question, and this is the kind of solution you get at the end, and you don't simplify it, well, you're going to lose a point, maybe a half a point. It depends on the situation. So you're going to get credit for most of the problem, but if you don't simplify it correctly, you are going to get penalized some for it, okay? So, it adds up after a while. So, if you have 8 or 9 problems on the test, and you don't simplify all 8 or 9 of those, and they all simplified, then you're losing 8 or 9 points. So on an individual basis, it's not too big a deal, but it adds up if you have a bunch of problems like that. So those are things you want to try to avoid if at all possible. And I'm also thinking about you in terms of college algebra. When you go into college algebra next semester, your college algebra professor is going to want you to simplify expressions and simplify answers. So I'm thinking, long term, what you're going to be facing in college algebra. So, all right. So we've got the square root method taken care of. So we are now ready to move on to completing the square. Not going to spend quite as much time with completing the square. To me, this is not as it's not as common for us to use completing the square as it is the square root method. Square root method you're going to use a lot in college algebra. Completing the square you're going to use some in college algebra, but not to solve quadratics, but to do other things besides solving quadratics. So with completing the square, this is a way of forcing any equation to be solvable by the square root method. So this forces all quadratics to be solvable using the square root method. And really, the word force is in this case, valid in that you've got an equation that's not in this nice form, something squared equals a constant. So we're actually going to go out of our way to force it to be in that form. So this is a typical equation, x squared minus 6x plus 10 equals 0. Let's say, instead of plus 10, let's say minus 10 for now. All right, see, so first of all, not factorable. X squared minus 6x minus 10 is not factorable. So you can't use the factoring method. It's also not in the form something squared equals a constant. So the square root method, it seems to be out here, right? Both of the methods we've talked about don't seem to apply in this problem. So what we're going to do is complete the square to actually put this in the form where we can use the square root method. And so what I'm going to do is show you how to complete the square. All right, and like I said, we're going to only look at this with relatively simple equations. We're not going to go out of our way to find equations that are because completing the square can get to be really, really messy, and we're not going to do that. So what you do is, first step is you move the constant to the other side of the equation. Move the constant to the other side. Right, so notice what I did here is I added 10 to both sides of the equation. Also notice that I leave a space where the 10 was. So you leave a space also, right? And so the 10 on the left side of the equation is not there anymore, but I left a space. And the reason why I leave a space there is because I'm going to fill in that blank with something else. And so what you do to figure out what to add to fill in is you take the middle coefficient. So the middle coefficient here is -6, and you take that middle coefficient and you multiply it by 1/2. You're going to do two things to it. You're going to multiply it by 1/2, always 1/2, and that gives you -3. And then you're going to take that answer and you are going to square it and get 9. And so that is the constant you are going to add in this space right in here. You're going to put in a +9 right there. So you always take half the middle coefficient, you multiply it by 1/2, and then you square it. Now notice since you're squaring it, it really doesn't make any difference that it was negative. And I'll generally kind of ignore the negative here because you're going to always, the second step is always to square it. And since you're always squaring it, it's always going to be positive. You're always adding a constant there. So you add the 9 there, but you remember, you can't just add a 9 to one side of an equation unless you add 9 to the other side also. So you have to add the 9 to both sides. All right? When you do that, what always will be true is this trinomial that you're left with right here, this will always factor. And the good news is it always factors exactly the same way. It always factors as the square of a binomial. So you could put parentheses down because you know it's going to factor as a perfect square, always. And it always factors the same way as the square of a binomial also. It's always the square root of the first term. And I'm going to write this again over here. It's the square root of the first term, so that's x. It's always the sine of the second term, so that's minus. And it's always the square root of the third term, 3, like that. So it always factors that way. The square root of the first term, sine of the second term, square root of the third term. So this factors x minus 3 squared, and then this is equal to 19. And so notice what you've done by this little trick that we just used right here is you've taken an equation. Here's my original equation. Looks like it's in a form where we're going to have a hard time solving it. It doesn't seem like it's solvable using the square root method. And what do we do here? We changed it so that it was solvable using the square root method. All of a sudden, it is in the form something squared equals a constant. And so now you use the square root method. Now use the square root method. This is always the way completing the square works. Is you're always going to figure out a constant to add to both sides of the equation to force the left side to factor as the square of a binomial. And then you can always use the square root method at the end of the problem. So you take the square root of both sides of the equation and you get x minus 3 equals, don't forget the plus or minus, and you get plus or minus the square root of 19. 19 is a prime number. It has no factors besides 1 and 19, so it is not something you can simplify any further. So you just leave it as the square root of 19. And then finally, you would solve for x by adding 3, and you get 3 plus or minus the square root of 19. And that's my solution set, 3 plus or minus the square root of 19. Right? And we've solved the equation by completing the square. Okay, so we're going to move on to another example. Is everybody okay? Anybody have a question about that particular problem?
No, I don't, but I do have one question. On the exam, like some past teachers have like made us do like each one. They've given us a question and they told me to factor it using one of the methods that they gave us. Do we have to use this method on the test?
Oh, on exam 3, if there's going to be questions where I'm going to say solve this used by completing the square. Absolutely. This is a method I want you to know. And so on the test, this will be exam 3 now, Brandy, not on exam 2, because this material is where exam 3 starts. But yeah, there's going to be a question on there, and it's going to say solve this quadratic by completing the square. And
so we do need to know how to do this.
Yeah, right. Absolutely.
Okay.
Absolutely. And so if you solve it correctly but use the wrong method, then you're not going to get credit for the problem, because this is a method that I want you to be able to show me that you know how to use it. So when you walk into college algebra, you need to be able to complete the square to look at various different kinds of problems. You need to know that process. So I'm just thinking about you as a college algebra student, and definitely college algebra students are going to need to know how to do that. So. Is
it possible you could do another example?
Oh yeah, I'm not done. Okay. So. Hey, I haven't. This isn't the first time I've gone through this. I know, I know this is a tough method, and I know students are going to struggle with it. So, no, we're going to work some examples. So, but we aren't going to work the more complicated ones because I'm not going to ask you complicated problems. When you've got, like in this problem we just did, if there was a number in front of the x squared, then like instead of just 1x squared like this equation, if it was a 4x squared or a 9x squared or something like that, then it becomes more complicated to do completing the square, and it gets messier arithmetic-wise. We're not going to look at problems like that. We're just going to look at ones where the coefficient's a 1 at the beginning. Also, let me flip back one more time. The step where I take half the middle coefficient, right, in this problem, notice I had 6 times 1/2 was 3. Negative 6 times 1/2 was negative 3. Well, sometimes you end up with a fraction there. And again, that makes the arithmetic more complicated. And I'm just generally going to avoid the arithmetic issues on these problems. I just want you to know the basic idea for completing the square. All right, so next problem, x squared minus 10x, or let's say x squared plus 10x. Let's say plus 15 equals 0. All right, so once again, this is a quadratic that is not factorable, and it's not in the form something squared equals a constant. So we do need to use another method, and so we're going to complete the square to do this problem. All right, so we go through the steps that we just talked about. And so the first step is we move the constant to the other side of the equation. So I subtract 15 in this case, and I get x squared plus 10x equals negative 15. And then notice I left the space, right, this empty space right here, because we're going to fill that in with a different number. So now we take the middle coefficient, the 10, and we multiply it by 1/2. It's always 1/2 times the middle coefficient. And so that gives me 5. And then that number is squared. Remember, it's a two-step process. And so 25 is the number I'm going to add to both sides of the equation. So I've got this equation right here, and I'm going to add 25 to both sides. So I have plus 25 here and plus 25 over here. Right, remember you have to add it to both sides. And again, that's a common mistake. I'll see students frequently forget to add it to both sides of the equation, and then obviously it's going to, once you've done that, you've messed up the equation. You have to have the equation balanced, and so whatever you do to one side of the equation, you have to do the same thing to the other side. All right, so now remember that the left side is factorable, and the factors of something squared equals 10. And how this factors is square root of the first term, sine of the second term, square root of the third term. So this factors x plus 5 squared equals 10. And now all of a sudden the equation's in the form something squared equals a constant. And so now you can go ahead and take the square root of both sides of the equation. So you take the square root of both sides, you get x plus 5 equals plus or minus the square root of 10. Don't forget the plus or minus because it is the square root method, and the square root of x plus 5 squared is x plus 5, right? The square root of 10 does not simplify, because the only factors of 10 are 2 and 5. They're not perfect squares, and so there's nothing I can do to simplify that. So I'm done with the radical. And so now I solve for x. The only thing I need to do here to solve for x is subtract 5. And you get negative 5. I put that at the beginning. Negative 5 plus or minus the square root of 10. And those are my solutions right there. Like that. All right, and we are going to work one more example. Anybody have a question about this one? Okay, sounds good. And so our next problem is, let's say we have x squared minus 2x plus 8 equals 0. All right, and actually, I'm going to change that. Let me just change it a little bit. Let's say plus 9 equals 0. There's a reason why I did that. All right, so let's go through the steps. Let's see how this works out. So we move the constant to the other side of the equation. Right, so I subtract 9 on both sides. Right, so I've always moved the constant as your first step. And now you take the middle coefficient, the negative 2. Now in this case, I don't care that it's negative, remember. You can leave it in there if you want. Doesn't matter, because you're going to square it. You get negative 1. Negative 1 squared is positive 1. And so you're going to add positive 1 to both sides of this equation. Right, fill in the spot right here that we left with a plus 1. Make sure you add it to both sides. So plus 1 on both sides. Right, so that's definitely our next step. All right, and then you factor, right? And we factor the left side of the equation. And remember, the left side will always, always, always factor the same way. It'll always be, first of all, parentheses squared, right? It's a binomial squared. And then it's the square root of the first term, the sine of the second term, and then the square root of the third term. The square root of 1 is just 1. So you end up with x minus 1 squared on that side equals negative 8. All right, and then, so now we have the equation in the form something squared equals a constant. And so now we take the square root of both sides of the equation, use the square root method. Right now, use the square root method. And so when we take use the square root method, we get x minus 1 equals, right, the square root of x minus 1 squared is x minus 1, plus or minus the square root of negative 8. All right, now remember the square root of negative 8. Let me do this off to the side. That simplifies. And when you have the square root of negative 8, you know, first of all, it's a negative, and so when you take its square root, it's going to be imaginary, right? You get the square root of negative 4 times 2 when you break it up. And then remember the square root of negative 4, it's the square root of a negative number, so it's imaginary, and then the square root of 4 is 2. So you end up with 2i times the square root of 2. And so that's how the square root of negative 8 simplifies. And so you get x minus 1 equals plus or minus, and then 2i times the square root of 2. Now, sometimes in WebAssign, just to warn you, on WebAssign, you might see that written as 2 square root of 2 times I, like that, and the I will be at the end after the radical. But I never, ever write anything after the radical because I don't want it to be confused with what's underneath the radical. And so I always put the I at the beginning. If you are going to put the I at the end, then what I would do if I were you is I'd put parentheses around this like this. That way it's really clear what's under the radical and what's not under the radical. All right, and then finally to solve for x, I'm going to add 1 to both sides. I put the 1 at the beginning, and I get 1 plus or minus 2i times the square root of 2. And so these are all the solutions to the equation. 1 plus 2i square root of 2 and 1 minus 2i times the square root of 2. All right? And so we've completed the square. All right, so you've got I think we've got 3 good examples worked out, 3 or 4 good examples for completing the square. These are all very typical kinds of problems you're going to see. I'm going to avoid fractions. I'm going to avoid, well, just generally, I'm going to avoid fractions on these problems, and they can get to be really, really messy. So I'm going to be careful the kinds of problems that I'm going to assign you and give you on a test also. All right, and so then to finish the day, we briefly want to at least start talking about the quadratic formula. And so I'm going to write a little bit out about the quadratic formula here, and then we're going to shut this down. So in the quadratic formula, what you do is you take the equation ax squared plus bx plus c equals 0. Now remember, this represents every quadratic equation. It represents every quadratic equation. Every quadratic can be written in that form. So if you solve that, if you complete the square on this problem, and it's not easy to do, it's really messy, but if you complete the square on this equation, on this form, what you end up with at the end is this. You end up with, I'm going to put dot, 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 because there's lots of steps in there. You end up with x equals, and you end up with this very complicated expression. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And this equation right here is, or this expression right here is called the quadratic formula. Now notice this is, how do we get the quadratic formula? Well, we solved every quadratic equation at one time by completing the square. We did all of them at once. And when you do all of them at once, you actually end up with this formula that just involves a's, b's, and c's. And that is literally a formula for solving a quadratic equation. All quadratics can be solved using this formula. Literally a formula where if you can figure out the a, b, and c values, you just plug them in and you get the solutions to the equation. right? So if we have x squared, this is the only example I'm going to work right now, and then on the next lecture we're going to look at this in more detail. But if you have x squared minus 2x minus 3 equals 0, right, you compare that to this form, ax squared plus bx plus c equals 0, and we see that a, the number in front of the x squared, would be 1, b, the number in front of the x, would be negative 2, and c, the constant, would be negative 3. And so you literally take those numbers and you substitute them into the quadratic formula. And so you get the negative of b, so the b is negative 2, so you get the negative of negative 2 plus or minus the square root of b squared. I always put parentheses when I do the b squared, and I get negative 2 squared minus 4 times, and then I use parentheses here also. I use parentheses throughout the whole thing when I substitute into the formula. And there's a negative 3 right there. And this would all be divided by 2 times a, which is 1, like that. And so you get this really big, ugly arithmetic problem. But when you simplify this arithmetic problem, you get the solutions to this quadratic equation. Right? Remember, this was the quadratic we were solving right here. And so you get x equals, the negative of negative 2 is positive 2, plus or minus the square root of negative 2 squared is positive 4. And then you have negative 4 times 1 times negative 3. So notice there's 2 negatives in there. You end up with plus 12, all divided by 2. And then this gives us 2 plus or minus the square root of 16 divided by 2. We end up with a radical that's actually something we can simplify. The square root of 16 ends up being a perfect square, and so you get 4 right there over 2. And so you end up with 2 solutions. You end up with x equals 2 plus 4 over 2, which is 6 over 2, or 3. And you end up with x equals 2 minus 4 over 2, or negative 2 over 2, or negative 1. And so the solutions to this equation are 3 and negative 1. And we got those using the quadratic formula. Now, this equation ends up being factorable also, but we were practicing the quadratic formula here. Factoring would have been a much easier way to solve this equation, definitely. But I'm just practicing using the quadratic formula. All right, so we are going to definitely shut it down at this point. Does anybody have anything last they want to ask me that's listening live today? Anybody have anything?
No questions here.
Okay, Justin, sounds good. All right, so Brandy, we're glad you joined us today. This is your first time on live lecture, so and you were very active. You asked lots of questions. That was great. We're thrilled that you were able to make it live today, and I'm glad you asked some questions. That's great. So that adds a lot to the lecture when I get people asking questions. And so you guys have a great day. Remember, I'm on campus later this afternoon from 4 to 6. I'm on campus tomorrow from 11 to 1. The exam 2 window opens on Thursday of this week and goes through Tuesday of next week. So good luck preparing for the test. Definitely come by my office, either on-campus office or my online office. You have plenty of opportunities to do that over the next 4 or 5 days. And so have a great week, and I will be talking to you soon. Thank you.